sheet basically gives you the actual data given by the meteorological department, IMD department, and this gives you 117 years of data. It would be 117 entities from 1901 onwards, when the Britishers started recording the weather parameters. So this is all recorded data from IMD, and this records the rainfall every year in various regions of the country or states, and then overall Indian rainfall. This rainfall would be in milliliters. That's how rainfall is measured. So I want to basically find about predict the rainfall. What is the last entry here? 2017. So I want to predict the rainfall for 2018, 19, 20, and whatever it is. So I want to give that prediction. That is what IMD does all the time. They go to the predictions. They do regressions all the time. Just go up. Let me see the heading. In case of pandas, we would have done type head and we would have seen the entries and all, top 5 columns. Now do one thing. Just go up. Tell me what is the, this is multiple variables. There are multiple independent variables. So we assume here that different regions are contributing to the overall rainfall of India.
Yes.
The overall rainfall of India is a summation of everything. Sum of all the rainfalls becomes the overall rainfall of India. So what is the dependent variable here?
Dependent variables are here.
Dependent variable is only one. India. I want to predict what is the overall rainfall in India in 2018, 19, 20, 21, because it's still 17. And what are the independent variables? What are the contributing factors here? These are the various state rainfalls. These are the contributing factors. So now do one thing. Again, go back to, let me divide this exercise into two parts as multivariate data analysis, regression analysis. Dependent variables is India and independent variables are all these contributing parameters. So I will first of all take one multivariate example by taking Assam, Bihar and Gujarat together. So go to data analysis. Regression. Input Y range. What will you put, Saurabh?
Y range of sir India, the
dependent variable. Y range is always India. So take India, including the labels. Input exchange. Take the three states, first three states, which is your Assam, Bihar, Gujarat. Assam, Bihar, Gujarat. These are the three independent variables. Let's see how they are contributing.
Labels are
labels, and then on the residuals, click residuals and standardize residuals. Okay. I don't want to see plots in Excel, they're horrible. Now interpret the results. Now interpret the results.
Okay, so the y-intercept is 32809 ml. It means
no, first of all, when we have multiple R, because you have three independent variables differently, the multiple R is 0.6, which is okay. R square is 0.36, which is not so okay. When you take all the three variables, R square is drastically coming down. Adjusted R square will be marginally less than R square. So that means that it is not a very good model from the R square. R square is a very important parameter. Adjusted R square should be more than 0.6. The combined effect of all the independent variables on the dependent variable. Anova, don't take Anova as three this thing. Anova is basically just taking you the alternate hypothesis for these two parameters, regression and residuals. What is basically the alternate hypothesis? Alternate hypothesis is less than 0.05 because it is a very low value. When Anova is less than 0.05, it shows that it's a good model. It's a good model fit. In every regression, you do a Anova analysis, and it simply tells you it's a good model fit. But let's not get too much worried out there. Come to the third table. The intercept, the y-intercept is 32, which is the constant, and Assam coefficient is 0.13, Bihar is 5.6, 5.1, and Gujarat is 8.4. So you can just simply write an equation called y is equal to 1.3 a 1.3a plus 1.3a plus 5.1 b plus 8.45 g plus 32809. What does it suggest? It suggests in future, if I only know the value of A, B and G, which is Assam, Bihar and Gujarat, I will know the overall rainfall of India. This is what the model says. You have derived a model. In future, just plug in the value of A, B and G, Assam, Bihar and Gujarat, and you will know the value of Y. This is the rainfall of India. That's how the predictions are going wrong, because R squares are low and yet they are predicting. Just go down. We are not finished with this yet. Just go down. It actually gives you the predictions of all the years. So just go up. It automatically predicts. Now I want to find out basically the standardized residuals. I want to find the first standardized residuals between whether they lie between +2 and -2. So for that, I want to see what is the count of the standardized residuals more than +2. What is the count of residuals less than -2? For that, there is a function called count if. Just write count if. Because there's a condition, brackets, range, take the standardized residuals. Don't take the label because this is not advanced Excel. Comma, inverted commas, 2, give 2 inverted commas, greater than 2. What is the count greater than 2? Inverted commas, again bracket close. So there are in this column there are 2 values more than +2. Similarly, do count for less than -2. Count if range same. Inverted commas, less than -2, inverted commas close. What does it show you, Saurabh?
There are 2 entries in standard.
There are 4 outliers. My range of standardized, the count of standardized residuals should be between -2 and +2. There are 4 entries, 2 entries more than +2, 2 entries more than -2, which is okay. This is acceptable. 4 outliers are acceptable. So even though the R square is low, 0.36, adjusted R square is 0.434, that is low, but the standardized residuals tells me that it is an overall okay regression equation to go. There are multiple criteria for judging the regression equation. One is standardized. There are three ways in which you can talk about a model fit. One is basically the adjusted R-square parameter. One is basically the significance level of the Anova, which should be less than 0.05. Third is the number of residuals outside plus and minus 2. Now go to the master sheet again. Now go up, do the same exercise, taking Haryana, Kerala, Punjab and Saurashtra. Okay, what do you see here? You see a better adjusted R square.
Yes, like
In the previous model.
yes.
Anova is also less than 0.05. And now draw the equation. Y is equal to 6.845 H plus 2.92 K plus 5.44 P plus 4.91 S plus 32530. What does it show you? You can predict the rainfall of India by just finding what is the rainfall in Haryana, Kerala, Punjab and Saurashtra, which are H, K, P and S. Plug in those values and you will find the overall rainfall in India. Now just find the standardized residuals count if again. More than 2 and less than 2. Where did the sheet go? So what? How many outliers are there?
Total 5 outliers.
Is it better or worse than the previous one? Outlier wise.
Yes, we have 4 now, 5. So it means previous one was little bit better in terms
But previous was better from the standardized residuals point of view. But how about adjusted R square?
adjusted R square is this time much better in second.
So what is your overall judgment? Which model is better?
The second one. This one. Second one.
So this is the judgment of the data scientist, because there are multiple parameters which decide what is the model, because these are all prediction models only. So, but given the choice, adjusted R square would be a better criteria than just one additional count of standardized residuals. And now you have the equation based on the rainfall of 4 states. You can predict the rainfall of overall India. Similarly, after this class, you can take all the states together and create a greater multivariate equation. There is another exercise that I had given you that was for single regression. That is a very simple thing, because anyway you have done multiple regression. So you can also see the p values if you see the p-values in this particular exercise, all the p-values are less than 0.05, which means that each of these variables is having a significant effect. Because the alpha value is 0.05, each is having less than 0.05. Look at p-value here. You see the p-value? It is the p-value of Haryana, Kerala, Punjab, Saurashtra. Each is less than 0.05. Punjab, which is 0.07. So Punjab is not giving a good effect to the model in this case. The Punjab p-value is 0.07. Now come to the first exercise sheet. Look at the p-values here. All p-values are less than 0.05. So again, here all the p-values are giving a significant effect. Assam less than 0.5, Bihar less than 0.5, Gujarat 0.05, less than 0.5.
Sir, Assam is 0.22, sir.
Oh yes, Assam is 0.2. It is giving a null effect, which basically it is not contributing to the model. Assam is not contributing. One thing in p-value is basically you don't go by the quantity of p-value, you just go whether it's above threshold or below threshold. So in this model you can make out that Assam is not contributing. In the other model you will see Punjab is not contributing. This can also be done by the stepwise regression model, where you just take one variable at a time and then actually see the R factor and basically the p-value, and then you'll also find out the outliers. So another outcome which is coming is Punjab and
Haryana.
No, not Punjab. Punjab and Haryana. Correct. No, not Punjab, Haryana, and Assam. Punjab, Haryana, and Assam are not contributing to the model. They are not contributing to the model.
Take all the independent variables together, so there will be some other p-values.
Yes, absolutely. After this class, just do it yourself. Take all the independent p-variables. Okay, so we can close here, and we'll meet on Wednesday then.
Okay, sir. So,
we'll meet on Wednesday for the IDA class.
Sir, one last question is this.
Yeah.
Sir, do we have any ways in which we can try to, in Excel, do we have any ways in which we can deal with multicollinearity? Because I think certainly this data set will have some multicollinearity.
So advanced Excel you don't have multicollinearity. Even in normal Excel you have a simple Corel function, but there will be, you have to use lot of Excel formulas together. You have to simulate the multicollinearity factor as multiple formulas and then you can simulate. But you have asked a good question, because what I think I will do now, I will do one more thing that I remaining is basically chi-square and Anova. So I will do a chi-square and Anova on Wednesday, and on chi-square we simulate the formula using Excel only, because there is, again, if you see on advanced Excel there is nothing called chi-square. Multicollinearity you have a formula, you can simulate any formula in Excel, any formula. Plus, minus, division, multiplication, all those things keep on doing like we did in the Python. But if you are asking a single function, there is no single function of multicollinearity. Only correlation between two columns only, two ranges only. And you have, of course, correlation in advanced Excel. You can have a big matrix of as many columns. It will give you a good matrix.